Now let us talk about section 9.4, pigeonhole principle. So the pigeonhole principle looks very common sense. If we put n plus 1 or more pigeons into n pigeonholes, then at least one pigeonhole will contain 2 or more pigeons. Sounds simple, but actually, very often, applications of this principle are highly non-trivial. We start with simple examples. Among any group of 367 people, there must be at least 2 with the same birthday because there are only 366 possible birthdays. Who can answer the following question? In example number 1, what are pigeons? What are pigeonholes?
People are pigeons, birthdays are pigeonholes.
People are pigeons, possible birthdays are pigeonholes. Since we have more pigeons than pigeonholes, there will be a pigeonhole that contains at least 2 pigeons. Next, among a group of 11 people in the elevator of a 10-story building, there must be at least 2 who will exit the elevator on the same floor. What are pigeons? What are pigeonholes?
People are pigeons, the story are the pigeonholes.
Yes. Okay, example number 3. 1 million trees grow in a forest. It is known that no tree has more than 600,000 leaves. Show that at any moment there are at least 2 trees in the forest that have exactly the same number of leaves. Trees are pigeons. We have 1 million pigeons. And the number of leaves are pigeonholes. So, since there are more pigeons than pigeonholes, there will be a pigeonhole with more than 1 pigeon in it. Means at least 2. Any questions about these 3 intra-level examples?
When does it prove that there's 3 pigeons in a hole? Like, does that work for that problem too?
Well, here at least 2, not at least 3.
And why not? Why not? How would you say why?
Well, why not? Think about the following. We think about the number of leaves as pigeonholes. How many pigeonholes do we have?
600,000.
600,000. Now, let us place into each pigeonhole first 1 pigeon, 1 tree. So 600,000 trees will be taken. The remaining number of trees is 400,000. Now we place the remaining 400,000 trees into the same pigeonholes once again. In some pigeonholes, there will be 2 trees. But since the total number of pigeonholes is 600,000 and the total number of remaining trees is 400,000, there will be pigeonholes that have only 1 pigeon.
So what number would it need to be for it to be 3?
For 3 pigeons, it should be lesser than 1/2.
Yeah.
To assure that at any moment there are at least 2 trees that have exactly the same number of leaves, we can replace this number by any number which is lesser than 1 million. To assure that there are at least 3 trees, we can replace this number by any number which is lesser than half, lesser than 500 million.
So would a general pigeonhole principle be that kn plus 1 pigeons in n holes would have to have at least 1 hole with k plus 1 pigeons?
Yes, so if we want to replace 2 by k, we just divide 1 million by k minus 1.
Okay.
So this number should be lesser than 1 million divided by k minus 1. For example, in our case, k is 2. We divide 1 million by 2 minus 1 by 1. So we can replace this number by number which is lesser than 1 million. Any other questions here?
Would that necessarily ensure that you would have at least k trees, or that just make it more likely?
No, we are sure. We want to know for sure. Because once again, if instead of 600,000, we put 1 million minus 1, we still have more pigeons, which is 1 million, than holes. And we can apply the pigeonhole principle. This assures, we're not talking about probability, that if instead of 600,000, we put any number which is lesser than 1 million, there will be at least 2 trees that have exactly the same number of leaves.
Yes, I see. And I had an idea in my head and it was just wrong. Okay, thank you.
Next, 12 students wrote a dictation. John Smart made 10 errors. Each of the other students made less than that number. Prove that at least 2 students made an equal number of errors. Guys, how do we prove that?
There are 12 students, and any student that makes less than 11 errors, then there must be at least 2 students that made less than 11 errors.
So the maximum number of errors is 10. We have 12 students in total. 1 student made 10 errors. The remaining 11 students made 9 or lesser. So we have 11 students left. These students made either 9 errors or lesser. By the way, the number of possible errors is not 9 for the remaining 11 students, but actually 10, because it's from 0 to 9, 10 possibilities. We have 10 possibilities for errors, and we have 11 holes. We have more pigeons than holes, therefore at least 2 students made an equal number of errors. Here, a group of 25 students wrote a dictation. John Smart made 10 errors, and each of the rest made less than 10 errors. Prove that at least 3 students made an equal number of errors. How do we solve this problem?
Do you show that 10 is less than 25 divided by 3 minus 1?
So let us think about the total number of students is 25, but we exclude John Smart because the remaining 24 students made a lesser than 10 errors, correct?
Yes.
So the number of pigeonholes will be 10 because
You're getting from 0 to 9, right?
from 0 to 9, absolutely. So we have 10 pigeonholes and 24 students. If we put 10 students into each pigeonhole, then 10 students again into each pigeonhole. In each pigeonhole, there will be 2 students, but then we have 4 students left, which means there will be at least 1 pigeonhole with 3 or more pigeons. Any questions here?
What if John Smart had made 13 errors here?
So if we have 13 errors, then the rest made 12 or lesser. So we have 13 pigeonholes, 24 students. So we place first 13 students, then the remaining number of students will be 11. Therefore, we cannot guarantee that there will be a pigeonhole with at least 2 pigeons. Does this answer your question?
Yes.
So if you replace 10 by 11, then we still can guarantee that there will be at least 3 students, but we cannot replace 10 by 12. So in order to assure that at least 3 students made an equal number of errors, we can replace 10 by 11 here and here, but we cannot replace 10 by 12. Here, how many cards must be selected from a standard deck of 52 cards to ensure that we get at least 3 cards of the same suit? What do we do?
First, you need to know the suit is 4. There are 4 suits.
There are 4 suits. So what do we do next?
Well, each suit, I think, has 13 cards. I'm not sure.
Well, if you had four cards, and you could say that each card had a different suit. If you had 8, they could be 2 of each suit. But if you had 13, then you'd have to have 3 of each suit plus 1 left over. If it was 9, then.
So there are 4 suits. If we only select 8 cards, then it is possible that we get 2 cards of each suit. So 8 is not enough to guarantee at least 3 cards. However, if we select 9 cards, then we'll get at least 3 cards in each suit. So 9 is the least we can select to guarantee that at least 3 cards of the same suit. Any other questions here?
I have a question.
Yeah.
Could we use the ceiling function to help just shorten our reasoning when it comes to using this? Just say that like 9 is the lowest number of pigeons where our number of pigeons or the ceiling of the number of pigeons divided by number of pigeonholes is equal to 3, since we're looking for 3 cards of the same suit.
Yes, absolutely. We use ceiling function. Ceiling of 9 divided by 4 is 3. Was that your question?
Yes, it was. Thank you.